right. Hello, everyone. My name is Ali. Today we're going to talk about one of our recent invention on metal separators for recycling technologies. I'm a university professor at the University of Alberta. I'm a director of the University of Alberta Power Electronic Labs. Prior to University of Alberta, I've been in industries for about 10 years, startups mostly, and I've generated about 40 patents which are being used in industries. One of our latest startups, Spark Systems, which was a spin-off company out of Queen's University, actually was a company on solar microinverters. It could attract about $50 million investment, and right now is in the process of going IPO. So after coming to University of Alberta about 6-7 years ago, I gathered a group here, and I'm supervising about 25 researchers. In this project, there are about 4 researchers involved. The key engineer is Mohammad Shah Abbasi, one of the team members that who should be also present today here. And he's in his final year graduate students working on this separators. So, it's not working. Okay. So metal recycling is a large business. It's a sustainable process, and it can reduce significantly. It can reduce the air and water pollution significantly, and it can also lower the energy consumption significantly. And Canada is actually one of the largest producer of waste. We generate about 1 million tons of metal every year, and overall, on average, in worldwide, you can only recycle about 32% of the metal. For example, steel recycling in Canada can generate is generating about $3 billion a year. They can save energy to power about 2.7 million households for a year. So if you look at the different types of metals that we have for recycling, we have steel, which is ferrous, which can be attracted by magnets, and non-ferrous, which is like aluminum or copper. And their recycling is more difficult, it's expensive, either done manually or by eddy current separators. And these kind of separators are actually very expensive. So what you can see here is the conventional eddy current separators, and what we've proposed. This is the conventional one. It has one kind of electric machine connected to a big rotor. And this whole mass on the rotor, we have lots of permanent magnet installed, and this has to rotate at about 3,000 RPM to generate this electromagnetic round, so that it can actually repel the non-ferrous materials by the eddy current that is generated in them, induced in them. So this system, the conventional one, is actually quite large. It's the cost is very high. It uses magnets, which are rare material, and the maintenance and operating is very high, because you always have to rotate this mass, very heavy mass, and it's not portable. It's the assembly is difficult, and it consumes lots of energy. So that's why such systems are not very common, and only very special places they have such systems, especially, for example, in Edmonton, as far as I know, they don't even have anything like this. So what we're proposing is to replace this whole system with a piece of electronics. And so there's no movement, there's no mechanical electric machine anymore. So the cost is going to be much lower. there's no movement, so the maintenance is very low. And we have a special controllability because here we're doing it electronically. We can generate the electric machine, the electric field instantaneously, or change it. So we can separate different kinds of metals instantaneously at the same time on the same roll, so that each one of them will end up in a different basket. Then the power consumption of this is very, very low because this system actually does not have any mechanical parts moving at such a high speed. So what we've done so far is that we've built and designed and built the prototype of this and implemented in the 10% scale down of this is implemented. And we have a patent application that is being filed and will be finalizing in a couple of months. And we're asking for $100,000 to $300,000 initial investment to be matched with NSERC and other resources, get about the leverage of 3 times. And we believe we can finalize this for an industrial prototype size in about 1 year and 2. And this is a picture of the electronic board that we've designed with a structure that comes inside the rolling system. And that's about it. Thank you. If you have any questions, I'll be happy to answer.
And Christy, welcome back. We can't hear you right now, but we can see you. Great talk, Ali. Really enjoyed that. Just wondering where you are in terms of the looking for partners. Are you looking to spin out a company then and looking for someone to come on board as a commercialization partner?
Yes, exactly. So we're looking at different possibilities at this point. If we can attract, if we can get about $100,000 to $300,000, we'll be in a good position to partner with someone, make the first industrial size prototype, and then we can do a spin-off exactly like the other ones that I've done before.
Great. And I was also impressed by your previous experience. I guess you raised a fair amount of money and had the IPO, or it's coming out, I guess. What was your biggest lesson from that experience that you could benefit from here with this story?
You should be unique and one of the first ones. And that's what we did there. We were the first company in Canada doing that kind of microinverters, and third in the world. So very, on time, and we were innovative, and we're doing very similar thing here. This thing that we're proposing has no other counterpart, and no other company is doing this. This if you wanna compare this to some other technologies, it can be compared like an electric car compared to a normal car, gas engine car. So that has all these mechanical parts, and the electric car has removed all of those. And that's what we're doing here. We're removing all those mechanical moving parts and making completely electronic.
Sure, that sounds great. And just wondering on your IP strategy, how are you getting a really bulletproof IP portfolio? Because it looks to me like this is going to be very attractive technology that the competition will love to try and reverse engineer or whatever they can, right? So,
yeah, it's a very special design. If we, what we're doing is that we're covering all those special good designs that can generate the amount of electromagnetic that is needed for some application like this. And that should block any other, competitor to enter.
Okay. And just one last question. Unless anybody else has a question, feel free to chip in. Christy, I'm not sure if we can hear you yet, but we can see.
Can you hear me?
Oh, perfect. Yeah. Do you have a
God,
question?
I fixed it.
Hello.
Christy's back.
I got a new computer and my settings are all over the place. I have not sorted it out yet. It's been one of those computer days. I don't know if I missed this when I was reloading the page, but who are your customers? Like, do you go to like the big recycling facilities and give them a different option, or your landfills?
Yeah, that's a very good question. Any recycling facility or any companies who actually right now making all these recycling technologies, we can either sell the technology to them, or we ourselves we can ramp up the production and just sell them the final product. So it depends what path you want to choose.
And how big is it? Is it like the sea container size,
Oh,
or is
this
it
is
like a little thing you?
yeah, let me show you that. This material feeder, this roller and everything, this is like 1 meter by 2 meters. And our device, it will be actually embedded inside this roller. So it's very small. Ours is like just some structure that can go inside that roller, and it will hide there, right? So it will sit there.
Okay, thank you.
Yeah.
What's the hardest thing about scaling this? If you want to bulk manufacture this product, are you looking for partners for that, or what would be your ideal partner to really go to market with this?
Honestly, this is very straightforward to scale. It's a piece of electronic that can be manufactured anywhere. We've done in a previous experience, we did it in China, or it can be any contract manufacturer. And this part is just some special winding. We did it with 3D printing, but it can be just a simple structure that can be built to hold these windings, and the structure is quite simple. It can be very easily scaled up.
Okay.
All right. I don't have any other questions. Does
Okay.
anyone? There's no questions in the chat. I can see.
Well, we got maybe 2 more minutes. So unless anybody else wants to ask a question, I'm going to ask another one. So I'm just wondering about your team, and you've done this before. So you probably know you need a diverse skill set to really get to the IPO. What kind of skills are you looking for to help build out your team?
So, in this one, we need someone who's expertise in electromagnetics, and we have already have that person. Mohammed is the one, and we need people with DSP electronic parts, the power electronic and the electronic and the CPU, the what do you call it, the intelligent part, the DSP parts, and to program that. So these are different skill sets, and with like 4 people, this can be easily, produced as a product.